Hi, my name is Arshad, and here are some things I've worked on. For the first Tech Challenge Power Play season, I designed a multi-axis claw arm that could intake from both sides of the robot and stage its motion using finite state machine control. I designed a faster version 2 of the arm using motion profiling for smoother control. For the lift, I implemented motion profiling with full state feedback and finite impulse response low-pass filters to clean up sensor noise. I also implemented automatic heading correction using a PID. For the center stage season, I wrote calculations for an automated scoring system. I used OpenCV computer vision to detect April tags and apply perspective transform, circle detection, affine warps, and logical checks to get a clear image of the backdrop. From there, I ran a search algorithm over the board, identified all possible scoring actions and their consequences, and returned a list of scoring options ranked by predicted scoring value. The robot could generate a path, drive to the board, and automatically score a pixel. I designed an active intake with a motor-powered roller. I tested multiple roller materials until I found the ideal configuration. I also programmed an automated control scheme that only needed 2 buttons to control, using color sensors, Hall effect magnetic limit switch sensors, and neodymium locking magnets. I implemented field-centric driving using vector rotation, and solved friction issues in a community designed for dead wheel odometry, which I used for localization during autonomous. In the off-season, I learned the CAD master sketch method for designing custom parts. I designed a coaxial swerve drive for FTC. I ran torque and friction calculations, and eventually got comparable packaging to a mechanodrive. For the Into the Deep season, I designed and built a coaxial linkage extension, which powered an intake at the end of the extension through a coaxial belt run. Version 2 took into account the effective torque of the system. I wrote forward and inverse kinematics equations, modeling the linkage and extension position and velocity. I incorporated a gear switch mechanism to achieve a level 3 robot ascent. It took CAD sketches and torque calculations to ensure the gears remained in contact under the heavy load. To automatically intake game elements, I programmed OpenCV computer vision, detecting contours, rectangle bounding boxes, and then filtering by contour area and density. This helped identify lone samples that are easy to intake, that orients the robot towards the sample and extends the right amount. For the latest season decode, I've written forward and inverse kinematic equations, modeling the trajectory of the game element when we launch it. Thank you for watching.